Okay, what is the volume element though in polar coordinates? So as here, what we want to do is to make a tiny little cube by varying our 3 coordinates. So we can vary the radius to r plus delta r, and that will make a little extended delta r side for a cube. We can change theta. Now that draws a circle in, if you like here, say the zx plane, or some rotation into the xy plane of that. But what it does is that it makes a circle, and it makes a little arc like this, and the length of that arc is the radius r delta theta. So this gives me a side to a cube of length delta r. This gives me a side to a little cube that we're building up here of magnitude r d theta. The final thing, of course, we can do is to change phi. And what does that do? Well, naively you might think that it would give you an r d phi, but that's not right. Actually what happens, by a different colour, is that we draw a circle up here when we change phi, and the radius of that circle is not r, but it is in fact that distance there, which is r sine theta. So the length of the little arc that I draw when I vary phi is r sine theta delta phi. The product of those 3 is then the volume of some little sphere, and therefore I get r squared sine theta dr d theta d phi. Let's check we've got that right by calculating the volume of a sphere. So I'm going to divide a sphere of radius a up into many little infinitesimal cubes, and calculate the total volume of the space. So the total volume is going to be given by the sum of these infinitesimal areas, which is just the integral over each of r, theta and phi of this quantity. What do I have to vary them between? Well, I want to go to all points in the space below A, so I better vary r from 0 to A, phi over its full values, 0 to 2 pi, and theta over its full values from 0 to pi. We can break that up into the 3 integrals which are independent of each other. We take all of the theta dependence to the front. Then we've got the phi dependence, well, only d phi is there, the rest of things do not depend on phi. And finally, we've got 0 to a of r squared dr. So what do each of these pieces give us? This gives us a cubed upon 3. So I get r cubed upon 3 and then I put the limits in. This gives me phi, I put the limits in, I get 2 pi. And this guy gives me minus cosine theta evaluated between 0 and pi. And if you put these limits in and are careful about the sign, you'll find that this is 2. So we get to our answer, which is that the volume of a sphere is given by the product of 2 times 2 pi, that's 4 pi, times a third a cubed. And we get 4/3 pi a cubed, which is the well-known expression for the volume of a sphere.